All right, here we go with first lesson of the year. So we're just going to be doing first couple lessons on just kind of some reminders, prerequisite skills, things that you've learned in the past, and we just want to make sure you're grounded in these things before moving forward. So we'll actually be getting into the book in a few lessons. Remember, these are notes you can always print from my website and fill in the blanks with me. That way you don't have to write so much as we go. So first one starts off with just some notation issues. We have our interval notation as well as our inequalities. So these things are sort of interchangeable, so I just want to make sure we understand what these things mean. So they're asking us to do a couple things up here. We're just going to fill those in down below. So first things first, just as far as what these things mean, whenever you see the parenthesis, it means that we are going up to that number, but we do not include that number. Whenever you see the bracket like this one, that means you do include the number. So we call this inclusive or non-inclusive. So for this one, as far as the endpoints go, the endpoints would be -3 and 2. The number you see first is always going to be the lowest endpoint, and the one on the right is the highest endpoint. So we're going to see this going all the way from -3 up to +2. All right, but we're not including -3, we are including the 2. So for these guys, whether it's bounded or unbounded, it just has to do with whether it actually goes to a specific number or if it goes on forever. Like there's our little infinity symbol that you can see right there. I'm going to see if I can focus that in a little bit better. See if that helps. So anyway, this one we would say is bounded, right, because it goes from -3 to 2. This one we would say is unbounded because it goes on forever in the positive direction. So as we look at this first one, first thing they want us to do is convert this to an inequality like this one. So we're seeing all the numbers from -3 to +2. So we would simply say we're going from -3 all the way up to +2. So x, or numbers that are greater than -3, less than or equal to +2. So, and again, that all has to do with the parenthesis or bracket that you see here. So parenthesis means it does not equal that number. The bracket means it does equal that number. Don't also make sure you keep in mind, when we say it's all the way up to -3, but it doesn't include -3, that doesn't mean that we're going to -2, right? It doesn't mean that we're limited to just integers like that, right? This basically means we're going to -2.99999 forever and ever, right? So it's getting forever closer to -3, but we're never actually landing on -3. So there's our inequality notation. One of the other things they ask us to do up here is to give it a graph. So I know you guys have done this one before, but if we were to graph something like this on just a simple number line, we can do something like this. So we're going to go from -3 up to +2. But the way this book has you graph these might be a little different than the way you've done it in the past. They actually use the actual parenthesis and bracket. So in this one, we have the parenthesis at -3, we have the bracket at 2, and we're just connecting those two things together. So I know in the past you probably did it with like a little circle that's either filled in or not filled in. So like you would have said it goes from -3 to 2, and we would leave it open at -3 because it's not equal to -3. We would have closed it at 2 since there's the equal sign here, right? And we would have done it that way. I know like our Algebra 2 books show it this way, but anyway, this is the way this book does it, so this is the one I want you guys to know. And we already talked about some of the other details that you were seeing in here. So this is, right, we got a closed interval here, and it's open on the left side. So on this one, we're seeing this one go from 2 to infinity. So if our lower boundary is at 2, and again, we have the parentheses, so it would have been considered a bounded one, except we were heading off forever to the right, so this one's unbounded. So this one's going from 2 all the way to positive infinity. So those are simply the x's that are greater than 2. If we're going to do that in inequality notation, as far as a graph goes for something like that, we would just do something like this. So we're just going to put the 2 in here. We're going to put a parenthesis because they had a parenthesis, and then we are heading off forever to the right. So it would look something like this. And then last one here, now it's an inequality. We're going to write it as the interval notation. Again, we would say this is bounded because it's limited to the numbers between -1 and 4. As far as the endpoints go, right, this will always be the 2 endpoints, or would be the 2 numbers that you see here and here. So this one, if we were going to convert this to interval notation, the equal sign tells us to put a bracket. If there's no equal sign, then we're going to put a parenthesis. So this one simply goes from -1 all the way up to 4, but not including the 4. So again, this is inclusive and this is non-inclusive. If we're going to, again, throw that into a simple graph down here, just going from -1 to 4, and we're going to throw in the same symbols that we have in the interval notation with the bracket and the parenthesis, and it's just going to look like that. So let me jump down to this next one here. I'm just kind of really hitting the highlights. I didn't do all the examples that I felt you guys wouldn't need help with. I'm just trying to throw in some of the things that I thought we would need. So convert these to inequality notation or vice versa. Same thing we were just doing up above. So these are just kind of some extra practice ones, similar to what we were doing up above. So if this was like a typical class setting, these are things I would then have you guys try, and then we would check them. So you're welcome to just pause the video and give them a shot if you want. I'll go through the answers real quick in case you want to give these a try so you can check your answers. So first things first, anything that is that goes to an infinity, to the left or to the right, it would be unbounded. So this is unbounded, and so is this one. The other ones would all be bound. As far as the endpoints go, the first number you see is always going to be an endpoint, and the second number is always the other endpoint. As far as conversions go, just make sure as you're going through, again, the hard bracket tells you that it's inclusive. The parenthesis, by the way, we always put parentheses around infinity because it's not actually a number you can land on. So you'll always see a parenthesis when you see infinity. So from -2 to 3, again, we would do something like this. As far as that notation goes, and on the graph, just like the number lines we did right here, you would go from -2 to 3. You would go from bracket to bracket within those graphs. I'll just touch on a couple things here real quick, and then we'll move on. So this one goes from -infinity all the way up to 0, not including 0. So we would simply say that these are all the x's that are less than 0. And that would be the way we'd put it as an inequality. As far as the graph goes, again, we're just going to throw in a 0 right here. We have our parenthesis, and this guy heads off forever to the left, towards -infinity. So not a whole lot different on these. Just be careful on the little things, like whether it's a bracket or a parenthesis. And again, this one's x is greater than or equal to 3, as it heads off to the right forever. So let me jump over to the next piece here. So I actually want to show you guys something in the book for this one. Some properties on page 7 that you can take a look at for these. But I'm just going to give you a quick reminder here as we're going through the video. But if you need help remembering any of the properties, take a look right here at page 7 in the textbook, and that'll guide you a little bit. But just remember, for rules of exponents, if we are multiplying these two factors together, the rule for exponents would be to add them. Anytime you're dividing, we subtract the exponents. A power raised to a power, you multiply the exponents. So those are kind of some of the main ones I wanted you to see. Don't forget that you're treating normal numbers as normal numbers, right? The 7 and the 3 are not exponents. All we're doing is multiplying. So we would say 7 times 3 is 21. If I did n to the first times n to the second, their exponents would add up to a 3, and then as far as the m's go, their exponents would add up to 5. And so, as always, you're always welcome to pause videos, give things a try ahead of time, and then you can kind of see as I play it out if you got the same answer. So as I subtract exponents here, I'm going to do 3 minus 2 for the n, so n to the first, which we would just write as n. -1 minus -2, so you got to be careful on those with the negatives. Minus -2 turns into a plus, so we're going to get a +1 on that as well. So just z to the first, and that would be our answer. One last one here we'll go through. Powers raised to a power you multiply. So 4 times -2 gives us m to the -8. On bottom, this is a 3 to the -2nd power. I'm just going to write that because I just wanted to remind you real quick of what that tells us. Remember, negative exponents tell us to flip, right? They do a reciprocal. Anytime you move something to the other side of the fraction bar, you are changing the sign of the exponent. So if I bring the m down below, his exponent becomes positive. And if I move the 3 up above, his exponent becomes positive. And then, of course, I could do one more step to simplify and call this 9. So again, here's a few that if we were kind of going through all this in class together, this is where we would have you guys do a few on your own to try. So you're welcome to pause right here and give them a shot. I'll write out the answers so you can check them to see if you did them right. So remember on these guys, as we subtract, if you do get a negative, we can always move it down below the fraction bar in order to turn those into positive exponents. So this would be the best way to write that answer. And then last one over here, similar to the one that we did up above. Remember, if an exponent's already positive, you want to leave it where it's at. So this one is going to stay on bottom, and the k is going to come down with it. So we got 4 to the third, which is 64. Bringing the k down so that his exponent can become positive. All right, let me jump down here. We're looking at P1 and P2 for this first lesson here. So let me go through a couple of these guys. Standard form equation of a circle. So as you look at this one, remember that this is the general form for the equation of a circle. The h and the k represent the coordinates of the center. So that's going to be our h and that's going to be our k. And of course, r represents the radius. So we're going to stick a 6 right there. So that's the equation. We're just going to kind of fill things in here. So as far as plugging in the numbers, remember that the negative is already built into this right here. So the sign is always going to change. So if we put our -3 right there for h, so x minus -3 becomes x plus 3 squared. Same thing with our y is going to become y plus 2 squared. And then r squared, which would be 6 squared, which we do want to simplify, so it should look like this. As far as the zeros go, anytime you got zeros for either h or k, all you're going to get is just an x or a y squared on those. So it should look like this. With a radius of 7 squared, we would write as 49. So here's one if you want to pause and give that a shot before I throw in the answer. So it should come out looking like that as we simplify it. And again, we don't expand this or anything like that, because when they say standard form, that's what this is. This is standard form right here. So that's the way we want to leave it. Jump on down to this one. Just wanted to remind you guys of your distance formula. As we look at this, it comes up quite a bit in various chapters for different reasons. So you've seen this plenty of times before, but just in case, we're going to find the difference in the x coordinates. So x2 minus x1 squared plus the difference in the y coordinates. So y2 minus y1 squared. And then all that's under the square root. Super strong link between distance formula and Pythagorean theorem. That's kind of where that comes from. So when you do the whole a squared plus b squared equals c squared, right, which looks something like this. Well, if I wanted to isolate c, the hypotenuse, I would do that by square rooting both sides, right? So I'd have something like this, right? And then a would represent your horizontal distance, and b represent your vertical distance. So that a represents, here's the horizontal change, the b represents your vertical change, right? And so really Pythagorean theorem and distance formula are the same thing. It's even actually the same thing as the standard equation of a circle as well, right? If you were to isolate the r by square rooting both sides, you would be looking at exactly a formula that looks like this, right? So really all the same formula. We just sort of rewrite them in whatever format makes sense for the problem that we're doing. If I wanted to prove that three coordinates made a right triangle, what they want you to do on that, and I'm going to show you so that we can get through this a little quicker, is they would have you take the 3 points, find the distance between all 3 points, and then plug it into Pythagorean theorem to see if it fits, right? So does a squared plus b squared equal c squared? If it does, yeah, you know it's a right triangle, right? So as you look at this one, if we plug those into our Pythagorean theorem, it would look like this. And sure enough, it does fit the formula, so we would say yes, it does form a right triangle. You'll always know that your c value is the largest one, right? The two smaller ones would represent a and b. And goes hand in hand with that. We also are going to look at our midpoint formula. So remember, midpoint is just like kind of finding the average, right? So you add up the x's and divide by 2. Oops. So that gives us the x coordinate. If you add up the y's and divide by 2, it gives us the y coordinate. And we write those as an ordered pair. It's a point. So that would be our midpoint. And so you're going to run into a couple things like this in the book where maybe they're going to have you do it with letters instead of pure numbers. But real basic formula that I know you guys have seen a bunch of times. So just wanted to remind you of the formula as we are going to run into a couple of those. And then one last thing I wanted to show you. And then we'll call it quits here for our first lesson. So you guys all remember absolute value brackets tell you that the result is going to be a positive, right? So if we said negative 2 times 3, we know that is 6. But the absolute value of negative 6 has to do with how far you are from 0 on a number line. So it doesn't matter whether you're going to the right or to the left. My distance from 0 we always see as a positive, right? We always see distance as a positive number. This just becomes sort of the direction that you're traveling, whether it's left or right. So we know this would be 6 units from 0, right? Whether it's to the left or to the right. When you're doing it with stuff like this, they're going to ask you to not come out with decimals, but rewrite it without absolute value brackets. So really all you have to think about on this is my result going to already be a positive, and therefore I can just drop the brackets, right? Or would my result inside the brackets become a negative, and then this would turn it to a positive? So as I look at this, I know that pi is about 3.14. When I subtract 1 from that, right, obviously 1 is smaller than pi, so the result is automatically going to be a positive number. So in a case like this, I do not need absolute value brackets, because this means the same thing as this, since this is already a positive result. I wouldn't need those brackets. However, when you look at something like this, the square root of 6 we know is less than 10. So if I were to subtract these inside the brackets, it's going to become a negative. So if I were to just try to drop the brackets on this, right, this would not mean the same as this, because this has the brackets, which makes it positive. This doesn't have the brackets. This would come out to be negative without the brackets on it. So how do we make it so that they're the same while getting rid of the absolute value brackets? Well, we know that the result of this would be a negative. So if I just throw the negative in here and distribute it, right, we can write it this way, or it might even make more sense to flip the order and write it this way. So basically, long idea short, all we're trying to see on this is if I just flip the order of this, it now means the same thing, but I don't need the absolute value brackets anymore. And you would see if I were to type this into the calculator, and if I was going to type this into a calculator, it produces the same result, but this one doesn't need the absolute value brackets. So, and I already set that one up here so you could see it. So as I type in the original with the absolute value brackets, that's what I get. When I flip the order and drop the brackets, I get the exact same answer, right? So when they say rewrite this without the absolute value brackets, because it yields a negative result, all I have to do is flip the order and drop the absolute value brackets, and I'm getting an equal expression to what we started with. So let me just throw a couple more at you, and we're going to call it quits for the first one here. With something like this, where you're now dealing with variables instead of real numbers, it's the same idea. You just have to decide, do I need the brackets? Is it already going to be positive, or would it become a negative? If my x is going to be something greater than 5, so pick any number greater than 5 and put it right here, am I going to get a positive or a negative? Right? Well, any number greater than 5, when I subtract 5, I'm going to get a positive result, which means I do not need those absolute value brackets for x is greater than 5 when I write that expression. However, if x is less than 5, right, same idea that we talked about right here, if I use an x less than 5, well, now this is going to yield a negative. So if I were to drop the brackets in this case, my result would not equal the original expression, right, because this is overall positive, but if I drop the brackets, it would be an overall negative, right? And so I want their signs to be the same. So if you caught what we talked about in this case, all I really had to do was change the order in order for it to mean the same thing. And now I don't need the brackets anymore, right? So now when I do 5 minus anything less than 5, this now yields a positive result, just like this would because of the brackets. And that's it for lesson 1.